In the vast tapestry of the universe, stars are born, live, and ultimately die, each playing their part in an intricate cosmic dance. But what happens when a star reaches its end, its brilliant life snuffed out, and fate intertwines with a black hole? Picture this, a massive star, once resplendent and majestic, now teetering on the brink of collapse, drawn toward an entity that bends the very fabric of reality. This is a poignant story of life, death, and the awe-inspiring phenomena that await us in the cosmos. You might be wondering, how does a star's death relate to a black hole? What truly happens when these two cosmic titans encounter one another? Hold on tight, because as we explore this celestial drama, we will uncover revelations that might just challenge everything you thought you knew about the universe. Imagine this stellar giant, perhaps it's a supergiant star nearing the end of its life cycle. After eons of shining brightly, fusing hydrogen into helium and creating the very elements that make up our world, it reaches a catastrophic conclusion. As the core runs out of fuel, it begins to collapse under its own gravity. This is the moment of truth, a moment that could lead to a spectacular collapse. Yet, if this behemoth is within the gravitational grasp of a black hole, everything takes on a new dimension. Here's something you didn't expect: the fate of that dying star can dramatically vary based on how close it is to the black hole. If it's lying dormant in the cosmic shadows, the black hole may not seem like much of a threat at first. But cosmic distances are deceptive. As the star turns into a red supergiant and begins ejecting its outer layers, the tides of fate start to pull it inwards. With every gasp of its final breath, it releases tremendous energy, sending matter and radiation soaring into space. But wait, what happens next? That clinic of destruction, the black hole, starts to exert its gravitational influence. What is a black hole, you ask? In simple terms, it's a region in space with a gravitational pull so intense that nothing, not even light, can escape. It begins consuming the star's outer layers, stripping them away like a predator devouring its helpless prey. Can you imagine the sheer drama unfolding during this process? As the star's material spirals into the event horizon, the point of no return, the gravitational forces become overwhelmingly intense. The laws of physics, as we know them, begin to warp and bend. This phenomenon, called accretion, creates a disk of luminous matter spiraling around the black hole, radiating energy in brilliant bursts. Let's dig a little deeper. The infall of material generates intense heat and pressure, ultimately producing X-rays detectable across intergalactic distances. These X-ray emissions are not just random signals, they tell stories of chaos, catastrophe, and the imminent demise of the star. And while you might imagine doom and gloom, the truth is that this cosmic event can actually create spectacular fireworks in the night sky. As the star is drawn inwards, the jets of energy shoot out from the poles of the black hole. It's mind-boggling to think about, isn't it? On one side, there's the chaotic symphony of destruction, the star spiraling, being stretched and pulled, literally torn apart. On the other side, streams of energy shoot out at nearly the speed of light, as if the universe itself is trying to reclaim some of its lost glory. Let's pause for a moment to explore the implications of this grand dance. What lessons can we learn from a dying star meeting its end near a black hole? For one, it reminds us of the intertwined fates of matter and energy, of life and death, of creation and destruction. Isn't it beautiful, in a twisted sense, how both the birth and death of celestial bodies contribute to cosmic evolution? Every time a star dies, it enriches the universe with heavy elements that may one day coalesce into new stars, planets, and potentially life itself. Now, think about this: how might various sizes of stars react when facing the might of a black hole? Smaller stars experience a different fate compared to their larger counterparts. While the massive stars feed black holes and provide a spectacular light show, smaller stars may drift quietly, consumed slowly over eons, offering a stark contrast to the explosive end of their larger brethren. As we continue, let's focus on one particularly fascinating aspect: the phenomena of tidal forces. You see, as the star gets closer and closer, these tidal forces become increasingly significant. What are tidal forces, you ask? They are the gravitational gradient that occurs when an object is influenced by the gravity of another nearby massive object. Think about the sensation of waves rising and falling by the moon's pull on Earth's oceans. In the cosmic realm, this manifests dramatically. The side of the star closest to the black hole feels a stronger gravitational pull than the opposite side, leading to stretching and ultimately, fraying. You might be thinking, isn't this destruction a sad fate for a once bright star? Indeed, it is beautifully tragic. Yet, this violent demise is essential for the universe's overall growth and transformation. The material shed during this process, rich in complex elements that form the basis of all terrestrial life, will eventually contribute to new stellar birth. This cycle of death and rebirth is not just a cosmic irony, it's a fundamental process that speaks to the transient nature of existence itself. And let's not forget the auditory symphony this cosmic warfare creates. You may have heard the concept that in space, no one can hear you scream. However, as that star unleashes its final struggles, that energy and matter create waves, gravitational waves, rippling through space-time itself. When stars collide or are destroyed, these waves carry information about the event, traveling across the cosmos as echoes of their tumultuous end. Scientists now have tools to detect these waves, which could unlock profound insights into the workings of black holes and the universe as a whole. Let's step back for a second and reflect on the fact that we are witnessing the universe communicating. When a star dies near a black hole, it is essentially narrating its story through various means: light, sound, ripples through space. But what if that story isn't over? Maybe that dying star could leave behind something extraordinary, a remnant of itself. Enter the possibility of neutron stars or even black holes themselves as products of this stellar drama. A black hole could be born from supernova explosions, while neutron stars emerge from supernova remnants when the core collapses, creating a dense mass of neutrons. So where does that leave us? With remnants that either fade into obscurity or become cosmic guideposts, indicating where powerful forces are at play in the universe. Just the thought of it makes the mind swirl with possibilities, each event woven into the fabric of space and time, reminding us that as one star dies, endless stories are born anew. Here's something else to ponder: how would this cosmic ballet affect nearby celestial bodies? Would they be touched by the dramatic demise, or would they remain indifferent to the chaos unfolding near their distant neighbor? The gravity radiating from the black hole and the dying star could have profound effects, causing shifts in orbits and even igniting new star formation if enough material is flung out into the interstellar medium. So, what comes next will leave you speechless. We've only scratched the surface of what happens when a star dies near a black hole. In our next exploration, prepare to dive deeper into the realm of observations, how scientists detect these celestial events, the technology that allows us to glimpse the fading light of stars consumed by black holes, and the stunning revelations that redefine our understanding of the universe. What mysteries still lie undiscovered in the aftershocks of this cosmic dance? What might we learn about dark matter and dark energy through the remains of these stellar giants? As we unveil the next chapter in this stellar saga, prepare to be astonished, for the universe's secrets are waiting to be uncovered. Stay tuned, because the dance of the cosmos is far from over. As we set off on this next journey, let's delve into the methods astronomers use to unravel the cosmic mysteries generated when stars dance with black holes. We live in an age of unprecedented discovery, where our tools extend far beyond the naked eye, enabling us to witness the universe's narratives as they unfold through time. ### observational techniques, peering into the abyss. One of the most pivotal instruments in this quest is the powerful array of telescopes positioned around our planet and in orbit. Among them, the Hubble Space Telescope has provided awe-inspiring images deep into the cosmos, revealing distant galaxies and giving us insight into stellar life cycles. Using electromagnetic waves, ranging from radio to gamma rays, These telescopes help construct intricate maps of the universe, showing us not only the remnants of dead stars but also the glorious birthplaces of new celestial entities. However, when it comes to black holes consuming stars, we often rely on more than just visible light. X-ray telescopes, like the Chandra X-ray Observatory, allow us to detect the high-energy emissions from the accretion processes surrounding black holes. These X-rays are generated as materials are heated to millions of degrees while spiraling down toward the event horizon, serving as beacons of cosmic drama. Detecting these emissions helps scientists trace the history of star-black hole interactions, painting a clearer picture of their complex relationship. Moreover, in our pursuit of knowledge, gravitational waves, ripples in the fabric of space-time, have become a valuable source of information. The Laser Interferometer Gravitational Wave Observatory, LIGO, and its counterparts are now able to detect these minuscule disturbances, which occurred during cataclysmic events like supernovae or the merging of black holes. Each detected wave carries with it a story, a frequency that encodes the dance of masses far beyond our reach, revealing details about the progenitor stars and the nature of the black hole involved in their descent. ###the stories of celestial witnesses. But the universe does not speak solely through its well-known tools. There are countless celestial witnesses to these cosmic events. Surrounding star clusters and nearby structures can often bear the scars of such cataclysmic encounters. Exploring these regions can yield a treasure trove of knowledge. For instance, the remnants of supernova explosions, filled with heavier elements scattered throughout space, not only provide clues about the star's previous life but also enhance the interstellar medium. This material is vital for the formation of new stars. Here lies an intricate loop of creation, destruction, and rejuvenation that demonstrates how interconnected all cosmic phenomena are. On a more local scale, our own sun exists within a galaxy replete with the remnants of stellar explosions. Supernova remnants like the Crab Nebula act as celestial laboratories, allowing scientists to study the physics of stellar death, the processes that lead to neutron stars and black holes, and the aftermath of these cosmic events. By observing these regions, a mere echo of what has come before, we gain insights that inform our understanding of current stellar life cycles, including our own sun's inevitable demise. ###distant memories, light from the past. As we unravel further the brilliance of stellar deaths, let's consider the role of light in this cosmic theater. The light we see from a distant star is not simply a snapshot of its current state, it is a message from the past. When looking at the remnants of a star dying near a black hole, we are essentially peering back in time, interpreting images that reflect events that may have occurred millions, if not billions, of years ago. As we observe these phenomena, the Doppler effect plays a significant role. When a star approaches a black hole, its light shifts redward as it moves away from us and blue shifts as it draws near. This change in light wavelength offers clues about the star's velocity and motion in relation to the black hole, allowing astrophysicists to deduce critical information about their orbits and interactions. Each observation of these light shifts becomes a brushstroke on the vast canvas of cosmic history. But these insights aren't merely academic. They require relentless data curation and theoretical modeling to construct a cohesive understanding of the universe's evolutionary timeline. Data scientists and astronomers alike collaborate to analyze light curves and spectra, interpreting emissions to reveal the physical conditions at play in these violent regions of space. Such efforts help unravel the vast web connecting stars, black holes, and the dark matter and dark energy that permeate the cosmos. ###the collision of knowledge and imagination. Yet, amidst all this exploration lies a difficult truth: not all events are detectable or comprehensible to us. Much of the dark universe remains elusive, hidden away from our traditional methods of observation. Dark matter, which influences the gravitational dynamics of galaxies and clusters, shapes the environments in which stars and black holes exist. Meanwhile, dark energy, stretching the universe's fabric, continues to elude our grasp despite its crucial driving force behind expanding galaxies. So how do we forge ahead amidst such uncertainty? Here's where imagination and theoretical physics thrive. Researchers delve into simulations and particle physics to model scenarios of star-death dynamics and black hole formation. Groundbreaking work is being done to teach computers to analyze huge datasets, revealing hidden patterns that may point to the underlying physics governing these interactions. The blend of creativity, data analytics, and scientific rigor fosters dazzling advancements in our understanding of the universe. #future discoveries, unraveling the cosmic web. As we gaze into the future, the question remains, what further revelations await us? With upcoming space missions, such as the James Webb Space Telescope, we will enhance our ability to witness these cosmic collisions and interactions. Equipped with advanced instruments, JWST promises to peer deeper into exoplanetary systems and stellar nurseries that could ultimately lead to a better understanding of nearby star deaths and their influence on galactic evolution. Imagine a moment when we detect a distant star's last gasp as it succumbs to a black hole in real time. The knowledge acquired from such monumental discoveries may reshuffle our understanding of life cycles in the cosmos. Not to mention, how these events shape the neighborhoods when new stars are born from remnants. The interplay between life and death isn't just a cosmic curiosity, it challenges our philosophical views. It compels humanity to reflect and engage with profound questions about existence and the universe. Are we the watchers of a grand cosmic performance? Are we connected, in some ineffable way, to these distant stars born of the same elemental fabric? #A conclusion, the eternal dance. As our journey into the cosmos draws to a close, we find ourselves enriched by the stories unveiled through the demise of stars near black holes. The universe is a dynamically changing entity, woven together by cycles of creation and destruction. It's a theater where stars play their fateful roles, sometimes as radiant performers and at other times as tragic heroes, all while black holes stand as dark sentinels, their appetites insatiable. Every star that dies not only enriches the cosmos but also poses questions that propel humanity forward in its quest for knowledge. What does it mean to exist in this vast, mysterious universe? How do the lives and deaths of these celestial giants reflect the very essence of life itself? The intricate cosmic dance we've explored, illustrating both awe and destruction, ultimately embodies a universal truth, that within the heart of every death lies the potential for new beginnings. As we keep our gaze fixed on the stars, let us remember to embrace the wonder and uncertainty that comes with exploring the great unknown. While the cosmic narrative will continue onward, our role as observers and explorers ensures the eternal dance between stars and black holes will prompt us to seek answers and celebrate the profound majesty of the universe. The cosmos, vast and intricate, beckons us relentlessly. And who knows? Perhaps the next discovery we make will draw us even closer to unraveling the magnificent stories that these dying stars whisper into the fabric of the universe. Our adventure is just beginning, and as we continue this journey into the cosmos, let us remain curious and open-hearted, for the universe holds its secrets close, waiting to reveal them to those bold enough to seek.